afternoon, students. It's our third video, class 10th. Today, I will teach you how to find out prime factorization and to find HF and LCM using it. In previous video, I have taught you how to find out HF using Euclid's division lemma. In order to learn this process, we must know about prime numbers and composite numbers first. What are prime numbers? Fifth onward, we have studied about prime numbers. Actually, what prime numbers are? Numbers having, I am repeating this definition, numbers having only two factors. Only two factors are called prime numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are some of our natural numbers. Out of this set, we have to pick numbers which are not divisible by any other number except itself and by 1. So this 2 has exactly two factors, 1 and 2. 3 has exactly two factors, 1 and 3. 5 has exactly two factors, 1 and 5. 7. And then one more, 11 here. And you can find out these numbers. If the number is not divisible at all, it can be divided only by 1 and the number itself. You can say these numbers are prime numbers. Then what are composite numbers? The left out numbers except 1. Remember, I will take this case later on. Composite numbers, as definition, numbers having more than two factors. Numbers having more than two factors. Remember, our first composite number is 4. Why 4 is composite number? As factors of 4 are it is divisible by 1, it is divisible by 2, it is divisible by 4. So it has more than two factors. That's why it is composite number. You may revise this area of prime numbers and composite number from your previous classes. I have a book of lower class 5th, 6th and find out what prime numbers are. Case of 1. 1 is neither prime nor composite as it has only one factor. So remember, 1 is not included in prime numbers and it is not a composite number. So 1 is neither prime nor composite. Write down here. 1 is neither prime nor composite. Remember it. In various questions in probability, prime numbers are used or composite numbers probability for composite numbers in a group or probability of prime numbers in a group are asked frequently. If we are aware about this process, what prime numbers and what are composite numbers, and especially the case of 1, you can solve them easily. Otherwise, if you are making a mistake here, you cannot solve them. Remember, 1 is not included in set of prime number. 1 is not included in set of composite number. First prime number is 2. Second prime number is 3. 4 is not a prime number. Third number is 5, 7, 11, and so on. So I think this is sufficient revision for you. Now let's take next step. How to find out prime factorization of a number. If someone asks, find prime factors or find prime factorization of a number. To find out prime factors is some different technique, and to find out prime factorization is something different. Let's take an example. If I want to factorize this 8, then what should we do? I will divide it by 2 first. So 2 4 is 8. Next step, divide this 4 by 2. You will get 2 once again. And these are prime factors. But all these prime factors are the same. So prime factors, I'm using factors, not factor or factors of 8, and it is just same, only 2, as 1 is not a prime number. If I have to express this 8 as product of primes, then I should write 8 is equal to 2 multiplied by 2 multiplied by 2, or we can write it in exponential form, 2 raised to the power 3. So there is only one prime factor of 8, and that is 2. What is prime factorization of 8? It is 2 multiplied by 2 multiplied by 2. This expression shows product of primes. This expression shows how many prime factors are involved in a number. Listen one more thing. How to find out prime factorization? Here especially of composite numbers. We are dealing with composite numbers only. If it is prime, what should I find out? It's already prime. So only composite numbers will be taken to find out prime factorization. Let's have one more question. It's 120. Divide it by 2, you will get 60. Divide it by 2 once again, 30. You must know the divisibility rules first. 15. Now it is not divisible by 2. Try out by 3. It is divisible by 3. 3 5s are. And again, sorry, 5. 5 1s. 5 1s. 1 will not be included as it is not a prime number. So how can I express this 120 as a product of prime? 120 can be expressed as a product of prime as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. Or in exponential form, it can be expressed as 2 raised to the power 3 multiplied by 3 multiplied by 5. If you multiply these numbers, you will get once again 120. This is about prime factorization of a composite number. Sometimes students say, remember here, some of the students says, I am finding out LCM of 8. It is not LCM. This is prime factorization of 8. And sometimes we are doing silly mistakes. A student does his work as 2 4 ja 8 and he tries to divide it by 4 here and writes 8 is equal to 4 multiplied by 2. The expression is correct, but this is not as product of primes, as 4 is not a prime number. So I should not divide this number 8 by any composite number. So there should be no composite number in this factors, in these factors. If I am taking 6 here, 10, there are so many factors of 120. I can factorize 120 as 2 multiplied by 3 multiplied by 4 multiplied by 5. Whether this is a product as primes? No, I'm using 4 here. So this is not correct method to express 120 in as product of primes. I think now you are clear why I am not taking 6, why I am not taking 15, why I am not taking 10, and so on. Next, there is fundamental theorem of arithmetic. What is fundamental? It's basic. You are aware about theorems. Arithmetic, what do you mean by arithmetic? Branch of mathematics that deals with numbers, especially. There are other branches, algebra, geometry. So arithmetic is a part of mathematics. Sometimes student does not know about arithmetic. So this is the basic theorem when we deal with numbers. And what is this basic theorem? As I have seen in earlier examples, 8 is expressed as product of primes. 120 expressed as product of primes. So I can express every composite number as product of their primes. So this is the basic theorem of arithmetic. Here every composite number I have taken 8, I have taken 120, you can have 125, 320, 462, just any composite number. It should be composite, not prime. Every composite number, remember here, every number, I am not taking every number, only composite numbers can be expressed as product of primes. How can I express any number as product of prime? I have already told you earlier, which is unique except the order in which prime factors occur. What is this order of prime factors? अभी मानिए एक स्टूडेंट को मैं यही प्रॉब्लम और देता कि आप 120 को एक्सप्रेस करिए प्राइम फैक्टर्स में और उसका आंसर कुछ ऐसा आता कि वो शुरुआत में इसे 5 से डिवाइड करके चलता। 5 से डिवाइड कर लिया, फिर उसने 3 से डिवाइड किया, फिर 2 से डिवाइड किया, फिर 2 से डिवाइड किया, फिर 2 से। आई एम रिवर्सिंग दिस ऑर्डर. Some other student might have written it in form of 120 is equal to 3 multiplied by 2 multiplied by 5 multiplied by 2 multiplied by 2. Are these expressions wrong? No. This is just same, as I am taking same primes. But my order of writing these prime factors is different. If someone writes this prime factorization as this, or as this expression, or as this, there is only change of order of prime. So accept the order in which prime factors occur in the prime factorization of a number. So no matter whether I am taking this, generally we are taking this order in increasing order. Just I am writing 2 first, 3 and then 5. Higher primes are given a space towards right. So remember this. You have to learn it by heart. This is recitation. Just revise it 3 to 4 times and have a page and try to write this fundamental theorem of arithmetic. Learn it by heart. These 3 lines are so important for you in this chapter. So I hope you will learn. Now I am taking some examples. If someone asks, express 462 as product of primes, and this question can also be asked in some different language, or find prime factorization of 462. Both the questions are same. You have to learn this language. So what should I do now? I am taking the same color. First of all, I have to write 462 and I will start the process of division. Whether this number is divisible by 2. Yes? Then divide it. 2 2 is 4, 2 3 is 6, 2 1 is. Now, here look at this digit, ones digit. Should we divide it by 2? No, it is not divisible by 2. Why? As units digit is not even. Then what should I do? Then find out sum of digit. The rule of divisibility. Remember the rule of divisibility by 3. So is it divisible by 3? 3, 2, 5, 1, 6. Yes. Then divide it. 3 7 is 21. Remainder is 2. 3 7 is 21. Should we divide it by 3? No, as sum of digit is not divisible by 3. It is not divisible by 3. So what should I do? Obviously, it is divisible by 7 or 11 here. So divide it. And finally, 11 is divided by 11 and we get 1. So find prime factorization of 462. So 462 can be expressed as product of prime. I am using find prime factorization. I am not talking about find prime factors of 462. So 462 can be expressed as product of prime. It is 2 multiplied by 3 multiplied by 7 multiplied by 11. There is no repetition of same prime number. If there is some repetition, you can write exponential form as well. मान लीजिए 3 को 3 बार यहाँ रिपीट किया गया है, तो फिर we can write 3 raised to the power 3. 2 को 4 बार रिपीट किया गया, I can write 2 raised to the power 4. 7 2 बार रिपीट हुआ है, I can write 7 raised to the power 2. Or simply you can use this expression as well. So let's take some other example. I'm using same language here as earlier one, express 651 as product of primes. Can you? If yes, then take a page and do it. I'm using your time. Are you ready? Let's try. 6, 5, 1. Remember, initially it is not divisible by 2. Sometimes students try and they find that it is not divisible by 2. They cross it. It looks clumsy. So first of all, you have to be certain that this number is divisible by some number we are taking. So not divisible by 2, then try out for 3. Which number should we try? First of all, we have to think about 2, 3. Do you think about 4? No, not necessarily. It is not composite number. Next, 5, 7, 11, 13. And most probably, these numbers are divisible by 2, 3, 5, 7, 11. At this level, higher primes are not used. Simple cases are given to you. So, I have crossed this 2. This number is not divisible by 2. Should I try with 3? Let's take sum of digits 6, 5, 11 and 1, 12. Yes, it is obviously divisible by 3. So divide it. 3 2 is 6, 3 1 is 3, remainder is 2. Take 1, 21, 3 7. Is it again divisible by 3? Let's try out. 2, 1, 3 and 7, 10. No, not divisible by 3 now. Should I take 5? Do you remember the divisibility rule of 5? Yes. Had there been 0 or 5, we can divide it. If not, then don't try with 5, as this number is not divisible by 5. Do you remember the divisibility criteria of 7? It was somehow lengthy, but let's remind. Take twice of this unit digit and subtract from the remaining part of the number. You will get 7, sorry. If I am taking double of 7, it is 14, and find out difference of 21 and 14, you will get 7. Or obviously it is, you can see that it is divisible by 7. 7 3 is 21, 7 1 is, so I am taking 7. 7 3 is 7 1 is. Can you increase these numbers? Whether this 31 is divisible? Yes or no? Where should I stop? Let's have some try. 31, I tried to divide it by 2. Not completely divisible. I try to divide this by 3. It is not divisible. Sorry. It is not divisible, as remainder is 1. In this case, a remainder is also 1. Try by 5. 5 6 is 3 10 is 15. Here, these two numbers become same. When I try it by 7, quotient will be smaller. So, highest number you can check 7 4 is. Now this quotient becomes smaller than divisor. You can certainly say 31 is prime number. Do not try to divide it by 11, 13, 17, 19 and so on. it will be a long process for you. So I had decided that 31 is prime number. So if it is prime number, then no need to divide. Or if you are taking your prime numbers here, then go further. You can stop here 3, 7, 31. Just I'm taking prime factorization of 651 is equal to 3 multiplied by 7 multiplied by 31. Have you learned this process? How to learn? It needs practice. Take many more numbers from your book or from somewhere else, or think yourself and try it out yourself. You have to express 5 to 10 numbers as product of primes. Only then you can successfully do it. This is not a difficult process. It needs practice only. So I think you will do. My next step is to find HCF using prime factorization. Using prime factorization, find HCF of 462 and 651. So the topic is clear to you? Yes or no? Yes. Remember, I have taken the same numbers in order to reduce my time, save my time. In earlier cases, I have expressed 462 as the product of their primes and 462 have primes as 2, 3, 7, 11. Is it clear? 651 is expressed as product of 3, 7, 31. In this process, you can take this prime factorization from here, and I'm taking this prime factorization from here as well. These numbers has already been entered in your table here. I want to reduce time of video. So first of all, you have to take this 462 here and you have to express it in prime factors as in earlier questions. Next, 651, यहाँ आप ट्राई करते रहिए, ये प्रोसेस आपकी चलती रहे और इस तरह से अब 462 को अपने प्राइम फैक्टर्स की प्रोडक्ट के रूप में यहाँ एक लिस्ट हमने बना ली। 651 को भी दूसरे उसमें लेकर हमने इनको प्राइम फैक्टर्स के रूप में एक्सप्रेस कर लिया। यहाँ प्राइम फैक्टर्स जो आप देख रहे हैं वो ज़्यादा हैं, यहाँ कम है, डजेंट मैटर, कोई दिक्कत नहीं है। हालांकि नंबर ये बड़ा दिखाई दे रहा है लेकिन यहाँ 31 का भी बड़ा। ये समस्याएं आपको नहीं हैं कि यहाँ कितने हैं कितने नहीं। अब आपको HCF लेते हुए करना क्या है? अब आपको इस HCF का हल्का सा, जिसे हम कहते हैं ना, पोस्टमार्टम करना है। What does H stands for? Highest. C stands for common. F stands for factor. Highest common factor. So, talk about common factors only. This statement doesn't mention any prime or composite number. HCF may be prime, may be composite, or other than both of the numbers, just like 1. So common factor, whether 2 is common in both the series? No. Then no need to write here, as 2 is not a common factor. Should I write 3 as common factor? Look at this. 3 is included in both the numbers. So write down here 3. I am taking H here. Is there some more factor which is common? Let's try about 7. Is it common? Yes, of course. 7 lies in both of the prime factorization. So take 7. Is this 11 is present in this prime factorization? No. So no need to write 11. So I am rejecting 11, 2, and I am taking 7 and 3. I am taking only these circled numbers here. I am rejecting 2 and 11, and I am checking this from one number only. No need to go here or start from here. So there is no other common factor now in both the numbers. What should I do if 1, 3 is here? Only take 1. If this 3 lies in both of the prime factorization, 3 occurs 2 times, then we have to write 1 more 3. So you can take different examples. It will be clear to you if you are going to solve different problems. So HCF is now 21. What does this 21 is special about these numbers? If I am trying to divide these numbers, if I try to find out which number can divide 462 and 651, so I can have 1 can divide, 3 can divide both the numbers, 7 can divide both the numbers, and this 21 has a special property. This is the largest number. This is the highest number that can divide both these numbers without leaving any remainder, or can divide exactly. There will be no other number larger than 21 that can divide these two numbers exactly. 21 से बड़ी कोई ऐसी संख्या नहीं हो सकती. अब ये आपकी गारंटी है. एचसीएफ आपको एक गारंटी देता है कि मेरा जो आंसर आया है उससे बड़ी कोई संख्या से आप इन दोनों को डिवाइड नहीं कर सकते, और इससे एग्जैक्टली ये डिवाइड होंगे. नेक्स्ट, I'm taking these numbers, same 462, 651, and my instructions are find LCM of. In previous example, we have learned how to find out HCF. Now, the same knowledge will be extended to find out LCM. What should I do in order to find out LCM? So, if I want to find out LCM of these two numbers, I am taking the same prime factorization as I have solved in earlier examples. First of all, in your solution, you have to show prime factorization of 462. You can do it in rough work as well. Or 651 can be expressed as prime factors and make a table. No need to write it in table. You can simply write 462 is equal to 2 multiplied by 3 multiplied by 7 multiplied by 11. It is just enough. 3 multiplied by 7 multiplied by 31. I have represented this in box in order to make things clear to you. So what will be the LCM of these two numbers? This is notation 462, comma 651, means I am taking LCM of these two numbers. And what should I do now? In HCF, we have taken common factors only. Here, we have to take every factor. Remember, there is a difference between common factor and every factor. Yes? Take, just try. Only common factors will be taken once. I will not take 3, 3 twice, 7, 7 twice. I will take every factor. So, should I include 2 here? Yes. Should I include 3? If you are including 3, then no need to include this number. It has already been included. Yes, 3. Should I include 7? Yes. कॉमन के लिए एक लेते जाएं और एक 7 और होता तो वो भी आप एक कॉमन फैक्टर के लिए एक को रिजेक्ट कर सकते हैं। यहां एक 7 और भी होता तो वो आपको एलसीएम में शामिल करना पड़ता। सो आई एम राइटिंग 7। शुड आई टेक 11? यस। Should I take this 31? Yes. You have to take all these factors. Only you can leave this 3 for this and 7 for this 7. So I have not taken these two numbers. Why? Because these two numbers were included in HCF. आप देखते थे पीछे 21 आया था, तो यही कारण था। अब यहाँ वो 21 नहीं यूज हो रहा। सो ट्राई आउट, what will be your product? Multiply them simply. 6 7 जा 42, 42 को 11 से मल्टीप्लाई कर लीजिए। 11 2 जा 22, कैरी 2, 11 2 जा 22, 11 4 जा 44 to 46, and then multiply it by 31. I'm multiplying 462, 6, 18, 8, 12, 113. I think 2, 2, 3, 4, 1. 14,322. You can check it out. 2 3 जा 6, 6 7 जा 42, 42 multiplied by 11, yes, I think it's right. Yes. And we have found out about HCF. What was HCF of these two numbers? HCF of 462, 651 means HCF of these two numbers is 21. And what is LCM of these two numbers? 462, 651 is equal to 14,322. Is it clear? If yes, I'm taking these two numbers in here. Next, I will take these two numbers in next example. So I'm taking this information. Now I'm going to find out relation between HCF and LCM. Relation between product of any two numbers and product of LCM and HCF. So product of two numbers and product of their LCM and HCF. प्रोडक्ट ऑफ एल्शियम एचसीएफ थी क्या, मैं यहाँ कॉपी कर लेता हूँ। यहाँ हमारे पास एल्शियम एचसीएफ अलग अलग आ गए हैं। हमारे पास नंबर क्या थे, 462 था, 651 था। इनके प्राइम फैक्टराइजेशन क्या क्या थे, क्या आपको याद है? तो यहाँ हम उसे लिखना चाहेंगे। उसमें एक बीच में रिलेशन मैं आपको हल्का फुल्का सा दिखाऊंगा कि 461 और 4 I have to express this once again. Let's have 462 once again. 2, 3, 1, 2, 3, 7, 11। तो हमारे पास 462 की प्रोडक्ट थी। इसको मैं अब कॉलम वाइज ले रहा हूँ। 2 multiplied by 3 multiplied by 7 multiplied by 11. And what was the prime factorization of 651? 651 3 से डिवाइड हुआ था, 7 से, and 31 से। Product of these two numbers, I am taking product of these two numbers, 651। 651 के फैक्टर्स मैं यहाँ लिख लेता हूँ separately. It was a product of 3, 7 and 31. Are you sure? Yes or no? Product of these prime numbers. And what is this product? Can you remember? This 21 is here and product of remaining numbers is here. Simply you can do one more thing. Multiply 462 and 651 on a separate sheet and 14,322 and 21 on a separate sheet and check it yourself. So always product of these two numbers will be equal to product of their HCF and LCM, and it is true for only two numbers, not for three. Remember, product of any two composite number or prime number or natural number is equal to product of their LCM and HCF. I think I have made it clear, and if no, I am taking it this part as a revision once again. I will take this prime factorization. I am taking two tables here once again and their HCF and LCM. Remember, what was the prime factorization of? Here simply 462 can be expressed as product of primes as 2, 3, 7, 11, and 651 was expressed as 3, 7, 31. What will be the product of these two numbers? 462 multiplied by 651. This number can be written as 2 into 3 into 7 into 11, and this number can be written as 3 into 7 into 31. What is about LCM and HCF? HCF क्या था क्या आप जानते हैं? हाँ जी, हमने 3 और 7 लिए थे। 3 मल्टीप्लाइड बाई 7 हमारे पास आया था। एलसीएम में हमने कौन कौन से प्राइम फैक्टर्स इंक्लूड किए थे? सभी यूज किए थे एक्सेप्ट 3 एंड 7. So I have written 2, 3, 7, 11, 31. And check out what will be the product of these two numbers. Product of HCF and LCM. Product of HCF and LCM. I can write it in form of prime factors. It is 2, 3, 7, 11, 31, 3 and 7. What is product of numbers here? Product of numbers. It was once again 2, 3, 7, 11, 3, 7, 31. Check these two numbers. Is 2 included? Yes. 3? Yes. 7? Yes. 11? Yes. 3? Yes. 7? Yes. And 31? Yes. So all these numbers are unique. Same in both. Whether it is product of number or whether it is product of HCF and LCM. So this notation is sometimes written as HCF of number, two different numbers A and B, and we write LCM of two numbers A and B. So as a notation we write product of A and B A and B is equal to product of HCF of AB and LCM of same numbers. आपके पास यहाँ जो प्रोडक्ट आई थी, अब उसमें से हमारे पास सीधा सा एक शॉर्टकट बनता है A इंटू बी इज इक्वल टू HCF, ध्यान रखिए सेम नंबर्स का ही होना चाहिए, LCM। इन चारों में से यदि कोई एक एक्सप्रेशन आपको दी जाए, आपको HCF दे दिया गया, टू नंबर्स दे दिए गए, you can find out LCM by shifting this in denominator. Can you transform? ये दो नंबर आपको दिए हुए हैं, इनमें से एक चीज मिली है, दूसरी आपको निकालनी है। सो HCF यदि आपको निकालना है तो आपके पास एक्सप्रेशन हो जाएगी A मल्टीप्लाइड बाई बी अपॉन LCM। LCM आपको निकालना पड़े तो उसके लिए प्रोडक्ट ऑफ नंबर समटाइम्स इट इज एक्सप्रेस्ड एज प्रोडक्ट ऑफ नंबर और डिवाइडेड बाय HCF। यदि आपको A फाइंड आउट करना है तो प्रोडक्ट ऑफ एलसीएम एंड HCF multiplied by LCM, I am not taking dot here, upon B. And what will be the B value of B? It is HCF, product of HCF and LCM divided by A. I think this process is clear to you. So thank you very much for watching this video. I have taken some time in middle of this video and wasted 2 to 3 minutes in copying, or I'm not editing with this video and uploading the same. I'm not expert how to edit and how to upload this video, so I will upload the same and I will copy it. So this is a task which I have completed for you, suggested activity, and you have to find prime factorization of 612. Find prime factorization of 612. I'm not talking about find prime factors of. Find prime factorization of 1314. Using the above factorization, find HCF of both these numbers. As I have taken two different numbers here. And using the above factorization, find out LCM of 1314 and 612. Verify that product of 612 and 1314 is equal to the product of their LCM and HCF. This is the same work as I have taught you. Thank you very much for watching this video and try to